Communication by Lewis Thomas. Other creatures, most conspicuously from our point of view the social insects, live together in dense communities in such interdependence that it is hard to imagine the existence of anything like an individual. They are arranged in swarms by various genetic manipulations. They emerge in foreordained castles, some serving as soldiers for defending the anthill or beehive, some as workers, bringing in twigs of exactly the right size needed for whatever the stage of construction of the nest, some as the food gatherers tugging along the dead moth toward the hill, some solely as reproductive units for the replication of the community. Even some specialized for ventilating and cleaning the nest and disposing of the dead. Automatons, we call them. Tiny genetic machines with no options for behavior, doing precisely what their genes instruct them to do generation after mindless generation. They communicate with each other by chemical signals, unambiguous molecules left behind on the trail to signify all sorts of news items of interest to insects. The dead moth is on the other side of the hill behind this rock. The intruders are approaching from that direction. The queen is upstairs and asking after you, that sort of news. Bees, the earliest and greatest of all geometricians, dance in darkness to tell where the sun is and where it will be in exactly 20 minutes. We, of course, are different. We make up our minds about the world as individuals. We look around at the world and plan our next move. We remember what happened last week when we made a mistake and got in trouble, and we keep records for longer memories, even several generations back. Also, we possess what we call consciousness, awareness, which most of us regard as a uniquely human gift. We can even think ahead to dying, and we cannot imagine an insect, much less a wolf or a dolphin or even a whale, doing that. So we are different and marvelously higher. Nonetheless, we are a social species. We gather in communities far denser and more complex than any termite nest or beehive. And we depend much more on each other for individual survival than any troop of army ants. We are compulsively, biologically, obsessively social. And we are the way we are because of language. Of all the acts of cooperative behavior to be observed anywhere in nature, I can think of nothing to match for the free exchange of assets and the achievement of equity and balance in the trade, human language. When we speak to each other, it is not like the social insects laying out chemical trails. It contains the two most characteristic and accommodating of all human traits, ambiguity and amiability. Almost every message in human communication can be taken in two or more ways. There are choices to be made all over the place, in the sending of messages and in their reception. We are, in this respect, unlike the ants and bees. We are obliged to listen more carefully, to edit whatever we hear, and to recognize uncertainty when we hear it or read it. Another difference is that the communication systems of animals much older than our species are fixed in place and unchangeable. Our system, language, is just at its beginning, only a few thousand years old, still experimental and flexible. We can change it whenever we feel like it, and have been doing so all along. How many of us can speak Chaucerian English, or Anglo-Saxon, or Indo-European, or Hittite, or read them? But it is still a genetically determined gift, no doubt about it. We speak and write and listen because we have genes for language. Without such genes, we might still be the smartest creatures on the block, able to make tools and outthink any other animal in combat, even able to think and plan ahead, but we would not be human. It is not clear whether the gift of language turned up because of a mutation suddenly transforming us from one kind of species into a distinctly different creature by the installation of brand new centers for language, or whether you get language automatically with a big enough brain. It could be either way. We could be human because of specialized centers designed for grammar, as songbirds evolved identifiable neuron clusters on one side of their brains for generating bird song, or we could be generating grammar and transforming it simply because we acquired brains huge enough to do this sort of thing. It is not a trivial question, and sooner or later we can hope to settle it, since it is a question open not only to speculation, but also to scientific inquiry. Did we become human because of acquiring the property of language, or did we gain language as the result of acquiring human brains? It is not a question for the birds, although the birds have hypotheses for us if we like them. The song sparrow sings his elaborate song, stereotyped in its general message, but ornamented by himself alone, because he possesses a large, sharply delineated cluster of neurons in the left frontotemporal cortex. If he hears the typical song of the species early in his life as a nestling, he will remember it 10 months later and sing it accurately, with a few modulations of his own. If he is kept from hearing it in his childhood, he will never learn it. If he is exposed to the song of another species, a swamp sparrow say, he will sing a strange medley of song sparrow and swamp sparrow sounds on maturity. If deafened as a nestling, he will sing nothing beyond a kind of buzz. The cells responsible for the song of a canary are typical, conventional-looking neurons, easily recognized in stained sections of the brain. But between mating seasons, they die away and vanish. Then, with the next spring, they reappear as full-fledged brain cells, synaptic connections and all, and the song center is back in place. This is a nice piece of news. Brain cells can die off and then can regenerate themselves. Until Notebaum and his associates at Rockefeller University learned this from their studies of birdsong a few years ago, we had taken it for granted that brain cells could not regenerate. Once dead, they were gone for good. We knew that the olfactory receptor cells out in the open nose can regenerate all the time, every 3 weeks or so, but that seemed an extraordinary exception. Now, with the canary to contemplate, we can begin to guess that maybe any part of the brain might be given the same capacity for regeneration, if only we knew more about the regulatory mechanisms involved. I never used to like canaries much, nor their song, but now, as a once neurologist, I hear them differently. As I said a moment ago, human language is probably at its earliest stage, just beginning to emerge and evolve as a useful trait for our species. When we first acquired it is not known, but we do possess something resembling a fossil record. Around 20,000 years ago, our human ancestors scratched marks on rocks, which Marshak and other scholars have interpreted as primordial arithmetic and accountancy. The Proto-Sumerian tablets from the 4th millennium BC contain clear records of calculation, mostly concerned with barley measures, based on sequences of 60 rather than the 10s used in our system. We can make good guesses about the origins, even the dates of origin, of many of the words in our language today, thanks to the scholarship of comparative philologists over the past 2 centuries. We can even see now from this distance how we made most of our metaphors from their words. True, for instance, from their deru for tree, world, for instance, from their wiros for man. Someone remarked just a few years back that we are much more knowledgeable than any preceding generation. T.S. Eliot, when told this, remarked, yes, but they are what we know. Human culture has evolved in a manner somewhat similar to biological evolution. If, in studying the development and variation of several different languages, you can find consistent similarities between certain words of those languages, you are permitted to deduce that another word, parental to all the rest, existed at some time in the past in an earlier language. It is the same technique as is now used by today's molecular biologists for tracking back to the origin of today's genes. The ordinary bacteria, for instance, have sequences in their DNA which are significantly different from those in the DNA of modern nucleated cells, and also just as different from those in the so-called archaeobacteria, the ancient anaerobic methane-producing bacteria very long ago. The molecular geneticists viewed this problem in the same way that the early 19th century philologists viewed the similarities of Greek to Latin and all the Celtic, Germanic, and Slavic languages, and of these to Sanskrit and before, and deduce the existence of an original language, Indo-European, antedating all the rest. For the molecular geneticists, a theoretical species called the eubacteria, speaking in ancient but still recognizable biochemical words, serves the same function as in Indo-European philology. I have invented my own taxonomy of language, not for the purpose of classifying different national or ethnic modes of speech, but simply to divide up language into the several different purposes for which it is used. My classification reduces language to 4 principal categories. The first category is small talk. This is human speech without any underlying meaning beyond the simple message that there is a human being present, breathing, and at hand. We use this communication mainly at social gatherings. The modern cocktail party is the best place to listen for it, but I have no doubt that an equivalent mode of speech has existed as long as society. The words do not matter, nor is grammar or syntax involved. The only messages conveyed are indications of presence. I am here. For this purpose, ritual phrases describing the weather, the route just taken by automobile, the flowers on the piano itself, suffice. This usage of language is also employed by humans for the declaration of territory, for the competitive acquisition of space within a room filled with other humans, and, on occasion, for the beginning of courtship. The second category is proper, meaningful language. This is where real cooperation begins. This is the marketplace of humanity. Thoughts are thought up, packaged, unwrapped, and packaged again, worried over, then finally put out, but never for sale, only given away. It is the strangest market in the world. Nothing is sold, no payment ever asked or received. Everything is given away in expectation of something to be given in return, but without any assurance. Speech is, at its best, the free exchange of thought. When it is working well, one human being can tell another everything that has just happened as the result of the explosive firing of 100 billion nerve cells in his brain, wired together by 1 trillion or more synaptic connections. No amount of probing with electrodes inserted into the substance of the brain, no array of electroencephalographic tracings can come close to telling you what the brain is up to. While a simple declarative sentence can sometimes tell you everything, sometimes a phrase will do to describe what human beings in general are like, and even how they look at themselves. There is an ancient Chinese phrase dating back millennia, which is still used to say that someone is in a great hurry, in too much of a hurry. It is Zhu Ma Guan Hua Zhu. Zhu means traveling. Ma means horse. Guan is looking at. Hua is flowers. The whole phrase means riding on horseback while looking or trying to look at the flowers. Precipitously, as we might say, meaning to look about while going over a cliff. Language is more than a system of signals and directions. It is a mechanism for describing what is going on within a mind. Most often, it is used for pointing out the connections between one thing and another seemingly different thing. It relies heavily on metaphor, using words and images fitted together in such a way that something quite new and different is revealed. The 14th century nun, Julian of Norwich, wanting to describe how the world seemed to her, wrote this, quote, "And he showed me a little thing the size of a hazelnut in the palm of my hand, and it was round as a ball. I looked thereupon with the eye of my understanding and thought, what may this be? And it was answered generally thus, it is all that is made," end of quote. The language is itself very simple, and the sentences seem and sound crystal clear, but this short section of Julian's revelations has reverberated in all its ambiguity down through 6 centuries, serving even the purposes of today's advanced cosmological physicists.